Good morning students and welcome back to another video lesson for class 10 physics. I hope that all of you have successfully completed your term 1 syllabus and you have done exceptionally well in your term 1 examinations. Now that we are complete with the chapters mentioned in the syllabus for term 1 in physics, we have to quickly switch over to the next couple of lessons. For term 2 in physics, we are left with two chapters. The first chapter is light, in which we will be studying about two important phenomena related to light. They are reflection and refraction. The second chapter is also dealing with light, in which we will be studying about the construction and the working of human eye. The name of the chapter is Human Eye and the Colorful World. So today we will be having the first lesson discussion, that is light, reflection and refraction. We'll be dealing with few introductory concepts related to light and reflection of light. So obviously the very first question that arises in our mind when this word light is to be dealt should be, what is light? We ordinarily see the objects around us in the world. However, we cannot see anything in a dark room. On lighting up the room, the objects present in the room become visible. Naturally, a question arises, what makes objects visible? It is the light, either emitted by the sun or by electrical lamps, tubes, CFLs, or any such source. The light itself is invisible, but we can see objects only in the presence of light. Thus, we can say that light is a form of energy which produces the sensation of sight. Objects which themselves emit light are known as the sources of light or luminous objects. The sun, stars, a burning candle, a glowing bulb, or a CFL, fire, they are all examples of luminous objects. On the other hand, objects which do not themselves emit light but are visible to us in the presence of light are known as non-luminous objects. Our rooms, books, chairs, tables, plants, clothes are all examples of non-luminous objects. When light from a source falls on an opaque object, it reflects the light. When this reflected light enters in our eye, we are able to see that object. Again, we are able to see through a transparent medium on account of transmission of light through the medium. There are a number of various common yet wonderful phenomena associated with light. Some of these are image formation by mirrors and lenses, bending of the path of light by a transparent medium, beautiful colors of rainbow, action of prism and optical instruments like microscope and telescope, twinkling of stars, and so on. We can explore these and such other phenomena around us by studying the properties of light. Truly speaking, light is a form of energy which can travel through vacuum as well as different transparent media in the form of electromagnetic waves having extremely short wavelengths within the range 400 nanometer to 700 nanometer. Visible light is usually defined as having wavelengths in the range of 400 to 700 nanometer between the infrared and the ultraviolet. These wavelength means a frequency range of roughly 430 to 750 tetrahertz. Now, at this point, I would like to give you a little bit of information regarding the electromagnetic spectrum and visible light. Generally, the EM radiation or EMR is classified by wavelength into radio waves, microwaves, infrared, the visible spectrum that we perceive as light, ultraviolet, X-rays, and gamma rays. The behavior of EMR depends on its wavelength. Higher frequencies have shorter wavelengths and lower frequencies have longer wavelengths. EMR in the visible light region consists of quanta called photons that are at the lower end of the energies that are capable of causing electronic excitation within molecules, which leads to changes in the bonding or chemistry of the molecule. At the lower end of the visible light spectrum, EMR becomes invisible to humans because its photons no longer have enough individual energy to cause a lasting molecular change in the visual molecular retinal in the human retina, which change triggers the sensation of vision. I'm talking about the infrared region. Similarly, above the range of visible light, ultraviolet light becomes invisible to humans mostly because it is absorbed by the cornea below 360 nanometer and the internal lens below 400 nanometer. Further, the rods and cones located in the retina of the human eye cannot detect the very short ultraviolet wavelengths and are in fact damaged by them. I would like to tell you that there are animals that are sensitive to various types of infrared, but not by means of quantum absorption. Like for example, infrared sensing in snakes depends on a kind of natural thermal imaging. Similarly, many animals with eyes that do not require lenses, such as insects and shrimp, are able to detect ultraviolet by quantum photon absorption mechanisms in much the same way that humans detect visible light. Various sources define visible light as narrowly as 420 to 680 nanometer to as broadly as 380 to 800 nanometer. Until, under ideal laboratory conditions, people can see infrared up to at least 1050 nanometer. Children and young adults may perceive ultraviolet wavelengths down to about 310 to 313 nanometer. In vacuum or air, light travels with an extraordinarily high speed, that is 3 into 10 to the power 8 meter per second. Our common experience about light is that light travels in straight lines. The simple fact that a small source of light casting a sharp shadow of an opaque object points to the straight line path of light, or rectilinear propagation of light. Now, when a beam of light is incident on an opaque object of very small size, we find that light bends around it and a sharp image of an object is not formed on the screen. Bending of light around the edges of an object of very small size is called diffraction of light. This phenomenon can be explained only on the basis of wave nature of light. In the beginning of the 20th century, some new phenomena were discovered which could not be explained on the basis of wave nature of light. So, at present, we say that light has dual character. Under one set of conditions, it can behave as waves, but under different conditions, it may behave as particles commonly known as photons. Wave particle duality is the concept in quantum mechanics that every particle or quantum entity may be described as either a particle or a wave. It expresses the inability of the classical concepts, particle or wave, to fully describe the behavior of quantum scale objects. As Sir Albert Einstein has written, that it seems as though we must use sometimes the one theory and sometimes the other, while at times we may use either. We are faced with a new kind of difficulty. We have two contradictory pictures of reality. Separately, neither of them fully explains the phenomena of light, but together they do. Through the work of Max Planck, Albert Einstein, Louis de Broglie, Arthur Compton, Niels Bohr, and many others, current scientific theory holds that all particles exhibit a wave nature and vice versa. These phenomena have been verified not only for elementary particles but also for compound particles like atoms and even molecules. So, as you can see right now on your screen, in the first picture, the dual nature of light. Light has both wave-like and particle-like nature. So, with the help of the particulate behavior, we can explain phenomena such as photoelectric effect. And with the help of wave-like behavior, we can explain phenomena such as dispersion of light by a prism. So, dual nature of light successfully explains all the phenomena connected with light. Reflection of light. Reflection is the change in direction of a wavefront at an interface between two different media so that the wavefront returns into the medium from which it originated. Now, in the diagram, you can see that very easily the term reflection has been explained in a very simple way. You can consider an example of a ball that hits the surface of ground and bounces back. Similarly, light too bounces back on hitting a surface. So you can see the basic definition of reflection of light, that it is the phenomenon of bouncing back of light after striking a smooth polished surface. Now, in the diagram, the very first thing that you should observe is that of a mirror. Now, a mirror is a smooth polished surface. A mirror provides the most common model for light reflection and typically consists of a glass sheet with a metallic coating where the significant reflection occurs. Reflection is enhanced in metals by suppression of wave propagation beyond their skin depths. Reflection also occurs at the surface of transparent media such as water or glass. Now, in the diagram, you can see that a light ray strikes a mirror at a point P and then it gets reflected. So, the light ray that is hitting the surface at point P, if I name it as OP, then OP is the incident ray, the ray of light falling on the surface. Similarly, PR is the reflected ray, the incident ray bouncing back in the same medium after striking the reflecting surface. Now, the point P is called the point of incidence, the point of the mirror surface where incident ray strikes and reflected ray bounces off. Now, in the middle, you can see the normal ray. It is the line drawn perpendicular to the reflecting surface at the point of incidence. So, between the normal and the incident ray, we have the angle of incidence marked with the alphabet I, and between the normal and the reflected ray, we have the angle of reflection marked with the alphabet R. Laws of reflection. Referring to the same picture, we can study the laws of reflection. If the reflecting surface is very smooth, the reflection of light that occurs is called specular or regular reflection, and the laws of reflection are the incident ray, the reflected ray, and the normal to the reflection surface at the point of the incidence lie in the same plane. The angle which the incident ray makes with the normal is equal to the angle which the reflected ray makes to the same normal. Obviously, the reflected ray and the incident ray are on the opposite sides of the normal. So in this diagram, if I mark the angle of incident ray as I and the angle of reflection as R, so as per law of reflection, angle I is equal to angle R. These two laws of reflection hold good for any type of mirror, whether it is a plane mirror or spherical mirror. Now, as I was telling you, that reflection of light is primarily of two types. Reflection of light is either specular or diffuse. In case of specular diffusion or regular reflection, specular reflection or regular reflection of light, what happens? Most of the incident energy is returned. Now, obviously, the type of reflection depends on the nature of the interface. In regular reflection, what happens if we are having a polished or smooth surface, just in case of a plane mirror, the kind of reflection we are observing, most of the incident light energy is getting reflected back. In this case, what happens? As most of the reflected energy returns in the same direction, so it produces a blinding effect. But if suppose the surface from which light is getting reflected is not a smooth or polished one, in that case, most of the energy gets absorbed by that surface. So that type of reflection is called a diffuse reflection or irregular reflection. Now, actually, most of the reflection that is taking place around us is diffuse reflection. I would like to introduce a term called reflector at this point. What is a reflector? An object having a smooth, polished and shining surface reflects most of the light falling on it. So silver and aluminium are two very good reflectors. A polished block of silver metal reflector may reflect even more than 96% of light falling on it. Image formed. When light rays starting from a point object after reflection from a mirror or even after refraction from a lens or prism actually meet or appear to meet at a point, then the second point is called the image of the given object point. So I'm just writing down the definition on your screen. When light rays from a point object after reflection or refraction actually meet or appear to meet at a point, then this second point is called the image of given object. As you can see in the definition, I have written that the reflected rays may actually meet or appear to meet. So accordingly, two different situations may arise, and namely we are having two different types of image, real image or virtual image. When light rays from an object after reflection or refraction actually meet, the image is said to be real image. A real image can be formed on a screen, and a real image formed by a mirror or a lens is an inverted image. The second category of image, that is virtual image. When light rays from an object after reflection or refraction do not actually meet but appear to meet, the image is said to be virtual image. A virtual image cannot be formed on a screen, and a virtual image formed by a mirror or a lens is an erect image. Now let us study about the image formed by a plane mirror. As you can see in the diagram, how the rays are traveling from the object named PP dash, and the image formed is given by QQ dash. Very easily you can trace the rays that is traveling from the object, and its image is getting formed by this flat mirror, or what is referred to as the plane mirror. Now in this case you can see that after the ray of light hits the mirror positions, it gets reflected, but the reflected rays do not actually meet at a point. Actually, they appear to meet at a point, and whenever there is an apparent intersection of reflected rays at any point, then that leads to the formation of what type of image? Obviously, it is going to be a virtual image. So, in this case, the image formed by the plane mirror is a virtual image. The four characteristics of an image in a plane mirror are that an image in a plane mirror is the same size as the object, the image is upright, the location of the image is the opposite of the mirror relative to the object, and it is a virtual image. Apart from this, there is a very important property shown by the image formed in a plane mirror. It is laterally inverted. Now what is lateral inversion? The interchange of the left and right sides in the image of an object in a plane mirror is called lateral inversion. So suppose we are having a mirror and we want to observe the lateral inversion. So commonly you might have seen that whenever you are standing in front of a plane mirror and raising your right hand, the image appears to raise its left hand. One more place where you might have seen the application of this phenomena of lateral inversion is in this word ambulance. Now you might have observed that in the vehicle it is written somewhat like this. So this is nothing but a direct application of the phenomena of lateral inversion, so that it becomes convenient for the person driving in front of the ambulance to identify what is written on the vehicle. So that's why the word ambulance is written already in an inverted manner, so that after lateral inversion from the mirror, that is the side view mirror, in the vehicle driving in front of the ambulance van, the driver concerned can easily identify the word written. So this is one of the applications of the phenomena of lateral inversion. So in our next video lesson, I will be discussing about spherical mirrors, some important terms in respect of spherical mirrors, and how image is getting formed by them. Thank you.